triangles, theorem number 3. Before we solve theorem number 3, let us repeat some basics which I taught you while I was teaching you the first theorem, that is the basic proportionality theorem. And before basic proportionality theorem, I also taught you the basics of triangles. So the repetition of those, the revision of these basic properties, some of the basic properties is important because they are used in solving or proving these theorems. Remember, try to recall, to prove the similarity of two triangles, I told you that you can prove by Aaa Similarity Criteria or Aaa Similarity Criteria. That's your choice. Alright. And number 2, I taught you that prove it by SSS Similarity Criteria. And number 3, I told you to prove it by SAS Similarity Criteria. Now, let us try to understand how you show the similarity and the congruency. The similarity and the congruency. Because it is important for me to clear the points to almost all category of students. Alright, here. Similarity, you use this symbol. Congruency, this one. So similar as well as equal. That is congruency. How you prove that the two triangles are similar by Aa Similarity Criteria? If we have two triangles here, this is ABC and this is DEF, then how you prove angle A is equal to angle D? Possible. Angle B is equal to angle E? Possible. Angle C is equal to angle F is also possible. A is equal to D, B is equal to E, and C is equal to F. Alright, by Aa Similarity Criteria, these two triangles are similar. For congruency, this is not possible. I told you already. Got it? So let us go to the SSS Similarity Criteria as well as the congruency. Alright, so let me draw this above so that you get the point here. This is one triangle, alright, and this is the another triangle. This is ABC and this is DEF. How do you prove that these two are similar by SSS? The similarity is when they are the corresponding sides are in the same ratio, not equal, right? Maybe equal also, that is also possible. Let us see here. How you say here, how you write AB by DE, alright, is equal to BC by EF is equal to AC by DF. AC by DF. So therefore, these two triangles are similar by SSS Similarity Criteria. What about congruency by SSS? Then this diagram is not possible. For that, the two triangles must be of similar as well as equal, both. This is EF. Alright. Now, in congruency, when it comes, how you write here? AB is equal to DE, alright, and BC is equal to EF, alright, and after that AC is equal to DF. AC is equal to DF. Look at that, the difference between similarity and congruency. Got it? Here, triangle ABC is similar to triangle DEF by SSS Similarity Criteria. And how you write there? Triangle ABC is congruent to triangle DEF by SSS Congruency Criteria. That's a difference. See how you prove the similarity by SSS and congruency by SSS. Important, right? Now let's think of SAS now. Alright. Now how we go with SAS here? Check it out. Now let me take the bigger triangle for similarity here. This is E and that is F. How I can go by SAS, and what is the definition for SAS here? When the two pairs of corresponding sides are in proportion and the included angle is equal, then the two triangles are similar by SAS criteria. Well, what is that? I said some statement. How to understand it? Check it out here. According to this, AB by DE, all right, AB by DE, AB by DE must be equal to AC by DF. AC by DF. And what? Look at this ABAC, ABAC. These two sides, ABAC, are including angle A. They are including angle A, not B and C. You should not take B and C. So, AB and AC are including angle A. So, angle A is equal to DE and DF. DE and DF. These two are including angle D. Angle D. Very important. So, by side angle side, by SAS, or you can say SAS criteria, the two triangles are similar. So you're going to write by SAS similarity criteria, both the triangles are similar. Now, suppose if you want to take angle B is equal to angle E here. What I said here, angle B is equal to angle E. Then what you need to do? Angle B is equal to angle E. Angle B is included by these two sides. And angle E is included by these two sides. Then those two sides must be in same proportion. So AB by DE, AB by DE, alright. AB by D is equal to BC by EF. BC by EF. Look, AB, BC, AB, BC include this angle. Angle B. Alright. BC and DE and EF, not BC, DE and EF. DE and EF include angle E, angle E. This is how you need to take. If you write this ratio, you have to take only A and D. If you take B and E equal or C and F equal, it is wrong. Absolutely wrong. Got it? So remember this. Got it? Now, how it is possible congruency by SAS? Check it out here. How is it possible by SAS? This is E and this is F. I take AB is equal to DE. AB is equal to DE. Alright. Angle A is equal to angle D. Angle A is equal to angle D. Alright. And AC is equal to DF. AC is equal to DF. So side angle side. Side angle side. So by SAS congruency. SAS congruency. Both the triangles are congruent. Look at how it is possible for similarity SAS and how it is possible for congruency SAS. Look at the difference. You need to observe those differences. Else, many students write this and say they are similar, and or some of them write this way and they say that they are congruent. Somewhere you are going to miss. Got it? So be careful with these explanations here. All right. One more point I need to explain here, that is BPT. What is that BPT? The basic proportionality theorem. That is theorem number 1. Understand? What is that theorem number 1 here? Check it out. If ABC is a triangle and this PQ is parallel to BC, then according to basic proportionality theorem, I told you that in triangle ABC, if PQ is parallel to BC, then what? It divides the other two sides in the same proportion. I repeat the basic proportionality theorem. If a line is drawn parallel to one side of a triangle, then it divides the other two sides in the same proportion. This is BPT, right? So let me write. Then we wrote here AP by what? PB. AP by PB. And usually you know what we took? That is DE. So there is no need to confuse. You need the logic. That's all here. And after that, PQ by QC. Sorry, AQ by QC. AQ by QC. This is possible. So for your convenience, let me take here DE only. Understand? So let me take this DE is parallel to BC. Then what I'm going to write here? Then what? AD by DB is equal to AE by EC. Understand here? So this is basic proportionality theorem. Now, when I was teaching you this BPT, I told you about corollary also. The corollary one is that this is BPT, all right. You can also, what is BPT? AD by DB is equal to AE by EC. You can also take AD by AB is equal to AE by AC. Let me write here. AD by AB is equal to AE by what? AC. This also you can write. You can write vice versa also. AB by AD is equal to AC by AE. That's your choice. And what is the second corollary? I can write here DB by AB is equal to EC by AC, or AB by DB. That's my choice here. Okay. DB by AB is equal to EC by AC. That is EC by AC. Or you can write vice versa. That is AB by DB is equal to AC by EC. That also you can write. The third corollary is very, very important to solve theorem number 3, theorem number 4, 5, etc. They're very important. What is that? Remember, if this is parallel to this, then the corresponding angles are equal. These two corresponding angles are also equal. And third pair is automatically equal. So therefore, ADE is similar to ABC by Aa Similarity Criterion. When the two triangles are similar, you can take the corresponding sides in the same ratio. Yes or no? I'm going to do that now. See, this triangle and bigger triangle. AD, smaller triangle side, by AB, bigger triangle side. Okay? Is equal to smaller triangle side AE by bigger triangle side AC is equal to smaller triangle side DE by the bigger triangle side BC. These are very important. And you know one thing? When they ask you in BPT to prove this, they may also ask you to prove this, not that. What they give a question, you know? In triangle ABC, if D is parallel to BC, prove that AD by AB is equal to AE by AC. They may ask. Don't think that always they are going to ask this. What you learned in BPT, first theorem. They give like this: in triangle ABC, if D is parallel to BC, prove that AD by AB is equal to EC by AC. They will ask. There, you must be ready. It is not there in textbook, but they asked in exams. So that is what I always tell you, to practice the logic, the concepts of mathematics. That's it here. And they may ask you like this: in triangle ABC, if D is parallel to BC, prove that AD by AB is equal to AE by AC is equal to DE by BC. They may ask you this also. Alright here. So these points are very important to revise, and I want you to remember this for this theorem. So straight away, without wasting time, let us go in proving theorem number 3. What is the theorem 3? If in two triangles, corresponding angles are equal, then their corresponding sides are in same ratio or proportion, and hence the two triangles are similar. I told you that if 2 comma, it is given. After then, it is to prove. Got the point here? So they talked of two triangles here. So let me take the two triangles. This is one triangle. This is triangle ABC. Similarity they are talking of. So let me take the bigger. This is DEF. Alright. This is DEF. So I told you that from here to here it is given, right? That is given. So let me write here given. So what is given to you? They have given you triangle ABC, and they also given you triangle DEF. And what else? Corresponding angles are equal. Angle A is equal to angle B they have given you, angle A is equal to angle D, all right, and these two are equal, they have given. Angle B is equal to angle E, angle B is equal to angle E, and angle C is equal to angle F. Angle C is equal to angle F. This is given to you. And what you need to prove? Number one, what you need to prove? The corresponding sides are in the same ratio. That means you need to prove AB by DE. Let me write here. AB by DE is equal to AC by DF. AC by DF is equal to BC by EF. BC by EF. And after that, and hence the two triangles are similar. So this is number two. I need to prove that triangle ABC is similar to triangle DEF. This is what I need to do. Now, let me give some more hints to you what to do. See, what they have given in this is the corresponding angles are equal. That's what they have given you. So they have given you that AAA criteria they have given. That means these two triangles are already similar, right? But still they are asking us to prove that they are similar. So that means you should not use this to prove that they are similar, because that is given. You need to use either SSS similarity criteria or SAS similarity criteria to prove that they are similar. Remember this. Suppose if they give you here in the given thing, I say, if the corresponding sides are in the same ratio, if I give this and after that they ask you to prove that they are similar, if the corresponding sides are in the same ratio, means they are already similar. But still, if they ask you to prove, means you have to take the help of AAA or SAS to prove that they are similar. So what about the third one? If they give that the two corresponding sides are in the same ratio and the included angles are equal, and prove that they are similar, then you should not use this property. From any one of these two, use it and prove that they are similar. So when it comes to this theorem number 3, what they have given you? The corresponding angles are equal. That means we are going to prove these two are similar by either SSS or SAS, not that. Got the point here? So think of that logic. See, before solving any question, look at the way we are supposed to give you the basics of entire mathematics from 8th and 9th standard as well as 10th standard. So we think of giving you ideas in such a broad manner. Then what about you? You are supposed to study the textbook as if you are researching something, not by hearting. It is not possible, right? So let us work together. Come to regular classes. I'm waiting for that. I will give you the best possible classes. Got it here. So let me proceed here. I'm going for the construction here. I'm going to construction. What is that construction here? I'm going to take P on DE such that DP is equal to AB. And I'm going to take point Q on DF such that DQ is equal to AC and join PQ. That is construction. Means AB is equal to DP and AC is equal to DQ and join PQ. This is the first one. All right here. So what I'm going to do here? Cut DP is equal to AB. All right. And what? And DQ is equal to AC. DQ. So let me write here. DQ is equal to AC. All right here. After that, join PQ. Right here. So straight away, let us go for proof here. Okay, proof. Now, why we took this? That's a question here. We are dealing with basic proportionality theorem. In basic proportionality theorem, a line must be there. We should be parallel to one side. All right. So using BPT, we are going to solve this theorem number 3 here. Now that means here, what I'm supposed to do is that according to BPT, PQ must be parallel to EF. I need to prove that first. Then the things become quite easy. So what I'm trying to prove? The corresponding sides are in the same ratio. That first I need to prove. If I prove this by SSS similarity criteria, both the triangles are similar. If I prove this, this is also done, right? So let us try to prove this one here. Got it? Now, let me proceed with it. How to prove that PQ is parallel to EF? I see that angle B is equal to angle E given. Angle C is equal to angle F given. If I prove that P is equal to E, then this is parallel to that. And after that, what happens? The corresponding angles become equal. That means what I can take here? B is equal to P also. Why? Why should we take that B is equal to P? Just think of that one here. Alright, so let us proceed here. So what I'm going to do first, check it out here. I'm going to take this part here. Alright, I need to prove this, right? So let me take these two parts here. And by SAS, let me prove that these two triangles are similar. Congruent. Like we can prove congruent because AB is equal to DP and AC is equal to DQ by construction, and they have given angle A is equal to angle D. That means these two triangles are congruent by SAS congruency criteria. So when these two are congruent, then angle B is equal to angle P. CT, corresponding parts of congruent triangles. But B is equal to E given. Therefore, P is equal to E. But these are corresponding angles. Therefore, PQ is parallel to EF. That is very important. Alright, here, if I get PQ is parallel to EF, then it's easy for me to prove this. Got the point? So let us prove that, let us write up to PQ is parallel to EF, then we continue, right? So see here. In triangle ABC, and triangle DPQ, ABC and DPQ, right? What we have? AB is equal to DP, alright? AB is equal to DP. There you are, by construction, alright? Next, angle A is equal to angle D. Angle A is equal to angle D. There you are, given, right? That is given. AC is equal to DQ. AC is equal to DQ. There you are. What is that? By construction. By construction. So therefore, triangle ABC is congruent to triangle DPQ by SAS criteria. Now, why I proved that? I can take that angle B is equal to angle P. Angle B is equal to angle P. So therefore, I can take here angle B is equal to angle P. CT. Understand here, what is that? CT. And also I can take that BC is equal to PQ also because they are congruent, right? What I can take here? BC is equal to PQ also. What is that? CT. Now, this point is important here, this one. But what I can take here? Angle B is equal to angle E given, isn't it here? Angle B is equal to angle E. What is that? Given. So from this, what do you get here? B is equal to B, therefore P is equal to E. Angle P is equal to angle E. Angle P is equal to angle E. These two are equal. Similarly, Q is equal to F also, of course, obviously. So, but these are corresponding angles, right here. But, okay, let me write above here. Here, what I'm going to write? But these are what? Corresponding angles. Which are corresponding angles? P and E. So that means therefore PQ is parallel to EF. So therefore PQ is parallel to EF. There you are. Now if you look at this triangle here, because we proved that PQ is parallel to EF, that means we can apply BPT, basic proportionality theorem. What? DP by PE is equal to DQ by QF. We can apply. This is BPT. Corollary 1. DP by DE is equal to DQ by DF. Corollary 2, PE by DE is equal to QF by DF. Corollary 3, dP by dE is equal to dQ by dF is equal to PQ by EF. This third corollary we need it. Got it? So that I am going to write here. So therefore I can say here what? dP by dE is equal to dQ by dF. Understand here? dF is equal to what? PQ by EF. What do you get here? PQ by EF. Right? What are you going to write here? By corollary of BPT, by basic proportionality theorem. Got it? Now why I got that? Compare here and compare over here. Why I got that here? Am I going to get the correct answer now? Of course. What is dP is equal to AB? So can I write here AB? Can I write here AB? So if I write AB by DE, there you are, AB by DE. DQ is equal to AC. That means I can write here AC. AC by DF. What is that? AC by DF. Alright, you got it. And is equal to what? PQ by EF. Understand here. What do you have here? BC by EF. But BC is equal to what? Look here. BC is equal to PQ. So PQ by EF. What is PQ is equal to? BC. So BC by EF. BC by EF. Proved. Understand? Look at the way you link everything. Understand? So look at the way you are supposed to understand the properties and what is given, what you need to prove. Your mind must be very clear. So you need lot of time to understand such questions and prove according to your convenience. So let us work together. Okay, I am there to help you in whatever the way you want it. I am just waiting for you here. All right, here. So let me proceed. So let me take this here. 1. All right, that is 1. And if I take this as, okay, this one, let me take it as 1. And this one, let me take it as 2. And this one as 3. So from 1, 2, and 3. What I got? dP is equal to AB. So instead of dP, I am going to write that AB by DE is equal to dQ. dQ is equal to AC. Instead of their dQ, I am going to write AC by DF is equal to, no, PQ is equal to BC. So instead of PQ, I am going to write BC by EF. Proved. So proved 1. All right, here we proved 1. What about 2? The two triangles are similar. Of course, here by SSS criteria, both the triangles are similar. So therefore, you can say triangle ABC is similar to triangle DEF by SSS, that SSS. Okay, similarity criteria. Understand the point here? So be clear and try to study this well. Okay, children, good luck and let's go to theorem number 4.